Hi everyone, this is Eddie Does Math. Welcome to my channel. If you'd like all the problems that I'll be solving today with my personal annotations, click the link below, enter your email, and you'll have it in your inbox in less than 30 seconds. Now let's take a look at some common mistakes students make on the SAT. Here's common mistake number one made on the SAT. It's confusion between the slope and y-intercept. In this question, we're asked to find the y-intercept. But students will see these 2 points and they'll immediately think, ooh, let's find the slope, which is not incorrect. So here we go, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So that's 4 over 2, that's equal to 2. And because the SAT is a time test, it's high pressure situation, students tend to rush. So don't rush, take it step by step. The students that do rush will click on 2 and boom, they think they're done with the problem. They won't even go back to check their answer. However, this problem is asking for the y-intercept. In order to find the y-intercept, we need to find the slope or the equation of this line. We have the slope. We'll use one of the points, preferably the easier point to use with the smaller numbers. So we'll have y minus 5 is equal to 2 times x minus 2. And we'll have 5 is equal to 2x minus 4, and then that plus 5 from the left side of the equation. That gives us 2x plus 1, and there's my y-intercept of 1 and not the slope of 2. The second mistake that I see students make is with averages, understanding that an average is everything summed up divided by the number of things that you have. So the average of n numbers is 10, meaning that whatever we had before, if we multiply n numbers times that average, that's the total number of things that we have in total. Now we're adding another number to this, and the average of all that becomes 12. But now let's think about how many things we have in total. We have n numbers of 10, and then we've just added one number. So we have n numbers of things plus that one x. And now we solve for x because we want to know what that added number is in terms of n. So we multiply both sides by an n plus 1, and that gives us 10n plus x. We get 12n. I'm going to take my own advice here and not rush. 12n plus 12, and that's equal to 10n plus x. So x will be 2n plus 12, which is letter D. The third mistake that I see students making is not answering the question that's being asked. They'll be rushing and they'll go, oh, this is easy. We multiply both sides by 2. We get 10, x is equal to 11. Boom, there's 11. I'm going to answer that. But don't forget, this question is asking for x plus 3. So 11 plus 3 is 14, answer choice D. Another example of this here, maybe a more complex one, is 3x minus 2. Don't forget to distribute this 2 to both terms. Another mistake that I see students making is forgetting to distribute this 2 to every term within the parentheses. So we have 2x plus 2, and we'll get x is equal to 4. But again, 4 is not the answer. Thankfully, it's not even an answer choice here. It would have been a good one, though. We'll plug in 4 here. 4 squared minus 4 times 4. We know that's 0. Boom, letter C. The next mistake that I see is students often try to memorize when they have no solution versus infinitely many solutions. But don't memorize and come to a better understanding of what these things mean. And let me show you what I mean by that. We have 4x plus 7 is equal to 4x minus 3. Notice how the 4x's will eliminate, leaving us with just 7 is equal to negative 3. But that is not true. It's never true. This is a false statement. Therefore, no solution of x, no value of x can make this statement true. Therefore, we have no solution. Now, if we wanted infinitely many solutions here, we would have had something like this. 4x plus 7 is equal to 4x plus 7. No matter what x is, this statement will always be true. Then we would have infinitely many solutions. Okay, so that's the difference between these two types of answers. Next, distributing negatives. I see students doing this all the time, even in some of my AP courses. We have negative and we're distributing them to the x and negative 4 first, but don't forget to do that. Or don't do that. We want to leave the negative on the outside and do x minus 4 squared first. And don't forget, when we do distribute this completely, don't forget that middle term, which is negative 8x plus that 9. So we'll have negative x squared plus 8x minus 16 plus 9. Again, remember to distribute that negative to all terms within the parentheses. So I have negative x squared plus 8x minus a 7. And that's answer choice B right here. All right, here we go. Quadratic solutions. Students struggle with this so much. Quadratics are maybe like, they show up a lot on the SAT. Out of the 44 questions, probably at least 7 to 9 questions will deal with quadratics. Here's what we need to know. What is the product of the solutions to this? So let's solve for the solutions first. Well, x squared is equal to positive 9. So when we take the square root of both sides, don't forget, it's the positive or negative square root of 9. So I have positive or negative 3. Product means multiply. So if we multiply a positive 3 times a negative 3, we get a negative 9, and that's our answer. A good answer choice that the SAT could have put here is an answer choice of 3, because I know a lot of students will just say, oh, 3 is the only answer here, so therefore, the product of 3 and nothing else would be 3 itself. Let's take a look at this one. Our last one. The equation here has two distinct. Distinct means different or unique. Negative solutions. So negative solutions means that when we factor this out, we'll have x times something and x times another thing equal to 0, and both of them will be positive. Both of them will be positive since we have negative solutions. Okay, so if we have negative solutions, we'll have and two distinct negative solutions, which the following could be the value of b. Well, let's think about this for a second here. We could have 8 and 2. We could have x plus 4 and 4, but that wouldn't give us distinct negative solutions. We could also have 16 and 1. And for this one, x will be negative 8 or negative 2. And for this one, x will be negative 16 or negative 1. And they want us to find the value of b here. And the value of b here should be 10 or 17, but seeing that neither of these are answers, they probably met two distinct positive solutions if we wanted to make these negative, and then I think they wanted to make the negative 10 an answer. So this might be a mistake on the problem's part. Let me know down in the comments if any of these are the answers and you could find them. But if not, those are all the mistakes that you could find.
Thank you for watching. If you learned something new, make sure to like and subscribe. And if you'd like all the annotations from today's video, make sure to click the link below, enter your email, and you'll have it in your inbox in no time. I cover SAT topics in my algebra and geometry courses. You can try it out for $7 for 7 days. I'll see you soon in my live lessons.